Hi, I'm Hazik.
I'm Nicholas,
I'm Safi,
We're from SPH4U Physics.
Taylor's College CPU.
and today we're going to talk about electron microscopes.
What is electron microscope? Electron microscope are scientific instruments that use beam of highly energetic electrons to examine objects of very fine scale. This examination can yield information about topography, which is the surface feature of an object, morphology, shape and size of particles making up the object, composition, which is the elements and compounds the object is composed of the relative amounts of them, and also crystallographic information is how the atoms are arranged in any type of object.
Electron microscope were developed due to the limitations of light microscope, which are limited by the physics of light to 5 times or 1000 times magnification and a resolution of 0.2 micrometers. Critical limit had been researched, and there was a scientific desire to see the fine details of the interior structures of organic cells, nucleus, mitochondria, etc. This required 10,000 times plus magnifications, which was just not possible using light microscopes. The transmissions electron microscopes was the first type of electron microscope to be developed, and its pattern exactly on the light transmission microscope, except that a force beam seen through the specimen.
So who invented the electron microscope? The electron microscope was invented in the year 1931 by Max Snell and Ernest Ruska. Their invention of electron microscope successfully overcome the barrier of higher resolution, the limitation of visible light had offered.
What are the main components of an electron microscope? An electron microscope has, firstly, an electron gun, which creates electrons, then accelerates them to a very high speed. Then it has the electron beam, which is created from the electron gun, which is aimed towards the specimen. It also has a vacuum chamber, which provides low pressure environment within the chamber. Without it, the electron beam will be interrupted by air particles in the atmosphere. Particles will also be knocked onto the specimen, distorting the surface of it. An electron microscope also has condenser and objective lens. Just like normal optical microscopes, the lenses are used to produce a clearly detailed image. Differences are, lenses are made of magnets that bend the path of electrons, which focuses and controls the electron beam to end up precisely where they need to go. The sample chamber is where the specimen is held. It needs to be very sturdy and insulated from vibration, as the scanning process is very sensitive. An electron microscope also has backscatter and X-ray detector, which tells the researchers about the components of the substance scans. A secondary detector also provides detailed image of the object's surface by registering secondary electrons, which are dislodged from the other surface of the specimen. Okay, now my peers are going to explain on how a scanning electron microscope and a transmission electron microscope works in detail. Stay tuned.
How does scanning electron microscope work? Source of electron is forced in vacuum into a fine probe that is rested over the surface of the specimen. The electron beam passes through scan coils and objective lens that deflect horizontally and vertically, so that the beam scans the surface of the sample. as the electron penetrate the surface of a number of interactions occurs that can result in the impressions of electrons or photons from through the surface. Reasonable fractions of the electron can be collected by opportunity detectors, and the output can be used to module the brightness of a cathode tube whose X and Y input and driven in with the XY voltage registering the electron beams.
How does the transmission electron microscope works? The electron beam is confined by the two condenser lenses, which also control the brightness of the beam, passes the condenser aperture and hits the sample on the surface. The electrons that are elastically scattered consist of transmitted beams, which pass through the objective lens. The objective lens forms the image display and the following apertures, the scattered electrons that will form the image of the microscope. Finally, the beam goes through the magnifying system that is consisted of three lenses, the first and second, which control the magnification of the image. So why do you use electron microscope? The smallest object of our naked eye can see about 0.1 mm in size, while light microscope can magnify objects up to thousands times of that. However, the electron microscope can provide a magnification by another thousandfold. For example, our naked eyes can probably see a grain of salt or even the thickness of our human hair. With the help of light microscope, we are able to see most of cells and even bacteria. However, the creation of the electron microscope, a whole new world has exposed to us, and even a greater range of objects can be examined with a fine detail. From the hairy surface of insect exoskeleton to the hairy surface of a cell in an organelles and their intricate interiors, the structures of virus, macromolecules such as DNAs of individual proteins, and even individual atoms which matter is composed.
What are the differences between a light microscope and an electron microscope? In basic terms, the most noticeable difference is that electron microscopy is more powerful and can achieve more resolution. In light microscopy, the cons lies in the diffraction limit of the resolution and out of focus light from the outside the focal plane, making the sample image blur. However, the pros is that light microscopy allows imaging of live samples and even track proteins in live cells. The cons of electron microscopy, on the other hand, is that the specimen is required to be completely stationary, meaning the sample cannot be alive, which makes it that you are able to view the shape of your protein, but not able to observe it changing its shape and carrying out its work alive. Now we're going to talk about on how an electron microscope has contributed to society. Ever since electron microscope were invented in the 1962, it is contributing every day to biologists and physicists in biological and science studies. Biologists and physicists use electron microscope to study the behavior of cells in human body and also the type of virus that they have to find and diagnose to find a cure.
This machine helps the scientists to clarify whether the diagnosis created by them is effective to curb the viruses. Even today, there are dangerous viruses and kills and spread to humans such as Ebola. Until today, scientists have not found any vaccine or diagnosis to curb this sickness. Many people get affected day by day, and electron microscope helps the scientists to study the type of virus and enable to create a diagnosis to kill the viruses. Moreover, electron microscope can give a clear image on an electron microscope. By this, they can identify how the structure of a cell in human body. This helps the scientists and doctors their research to curb the sickness of patient.
Electron microscope also contributes in industries. In industry, electron microscope helps in imaging of an object in 2D and 3D shape before a company produce its product. Most of our engineers use electron microscope as a failure analysis. This enables them to test the product such as strength and durability of an object to ensure their product is perfect for their customers. This also leads to safety purposes. In order to create a product, it has to be tested and it has to be safe. And it also contributes in a lot of products. In nanotechnologies, electron microscope is one of the important tools to magnify the image with the best solution up to 0.05 nanometers. This machine able to support to guide in industries such as 3D printer, stretchable gold, water, and stain repellent and artificial muscles.
And now we're going to explain on the technology behind an electron microscope. In modern technology, all electron microscopes use electromagnetism and electrostatic lenses, which consist of a coil of wire wrapped around the outside of a tube, commonly referred as a solenoid. In addition, electron microscopes use digital displays, computer interfaces, software for image analysis, and a low vacuum or variable pressure chamber, which upholds the pressure difference between the high vacuum levels essential to the gun and column areas and the low pressure required in the chamber.
By using technologies and surface nanoscale imaging is obtained that helps to understand the internal structure of microcomplex specimen. In electron microscope, images are produced from the interaction between the prepared samples in the vacuum chamber and energetic electrons. The electron beams pass through one or more solenoids, and with the aid of the thermionic electric gun is directed down the column and onto the sample. Using different techniques, the image size can be varied. Any changes of electromagnetic wavelength will affect the movement of the electron. For example, if you increase the voltage of the accelerating electron beam, you increase the size of the image.
When the energetic electrons come in contact with the sample, the reaction provides information on topography or surface texture, morphology or surface, which include the size, shape and arrangement of detectable surface, practice and the composition of elements and compounds, as well as crystallographic information which refer to the arrangement of atoms. This is how an electron microscope can be linked with an extraordinary technology power. That's it for our video.
Hope you guys learned something about electron microscopes.
If you have any question, please do comment in our video and we try our best to answer your question. Thank you.